Hi everyone, my name is Carly Lossie and this is my Physics 2212 Lab 1 Charged Tapes presentations. I hope you enjoy. In this lab, we found the excess electrical charge of a Scotch or clear tape. We did this using Coulomb's law, which is F equals K times Q1 times Q2 divided by R squared, which you can see below. By doing this, we hope to physically observe how a charge affects the tape's behavior. Now I will discuss models. The free body diagram that visualizes this lab is to the right. The two pieces of tape repel each other because they are both negatively charged. Please notice that the repulsion forces have an equal magnitude but are in opposite directions. Furthermore, the top tape floats with no net Y force, which tells us that the bottom tape completely counteracts the force of gravity. Now we will be moving on to our assumptions of this lab. First, we will need to ignore all of the air resistance on the moving object. Next, we will treat the long tape as though it were a point charge, with all of the charge concentrated at the center of the long tape. Now, before we begin discussing our GlowScript code and outputs, we will need to go over the data that we collected. First, the length of both of our tapes is 0.231 meters. The width of both of our tapes is 0.0225 meters, and the vertical distance is 0.024 meters. Moving on to our found values, we determined the tape's weight by multiplying the length times 0.001 kilograms per meter times the gravity constant, which results in 2.3 times e to the negative 3 newtons. The surface area is the length times the width, which equals 0.0052 meters squared. And finally, the number of atoms is the surface area divided by the area of the atom, which gives us 5.27 times E17 atoms. These values will all be very helpful in our GlowScript code. Now, looking at our GlowScript code, we can see that first we will input the necessary data in the constant section. Next, we create the objects of tape 1 and tape 2 that will be displayed as spheres on our model. Next, we will do all of our calculations that will determine 1. The charge on the piece of tape, 2. The magnitude of the electrical force acting on the tape, and 3. The number of electrons that are on the tape. Finally, we will create the arrows that are featured in our model. On this slide, we see our GlowScript outputs. These feature our model and the calculations that we found, such as the magnitude of the electric force that is acting on the tape. Lastly, we will answer the two critical questions of this lab. The first question is, what if electrons had positive charges and the protons had negative charges, and what would change about the observations of the tape? Overall, not much would actually change. The two pieces of tape would still repel each other, and the strips would keep the same charge. The second question asks why it's so important that the charged tapes are handled as little as possible. Because charged tapes holds the excess electrons, it is crucial that you do not interact with the tape too much because the tape will lose its electrons. This concludes my lab report for Physics 2212 Lab 1 Charged Tapes. I hope you enjoyed this video and found it at least a little educational. There will be a link to my GlowScript code in the description of this video if you wish to look at it closer. Thank you and have a great day.